Okay, let's just take another example. So here it says a linear problem with noise. It says in this hypothetical web page classification scenario, Chinese only web pages are solid circles. So here's a solid circle, here's a solid circle. These are Chinese only. And anyway, first of all, let's look at the axis. What's the axis here? The number of Chinese characters in the page. And what's the axis here? The number of Roman alphabet characters in the page. So I guess what they're saying is, even though we have a solid circle here, meaning it's a Chinese only page, so there's like, 450 Chinese characters in this page, but there's also about, 30 or 35 alphabetic characters in the page. So even though it's called a Chinese only page, I guess they still use some letters from the alphabet. So here I can see there's a lot of solid dots, and here I can see there are squares. So the Chinese only web pages are solid circles, and the mixed are squares. So can we draw a line that separates the two classes, the Chinese only versus the mixed? So we might say, okay, how about this line here? But it doesn't work because here's a circle. And so you'd say, okay, well, how about a line up here? But no, that's not going to work because we're going to get some circles and squares. So down, maybe over here, there are no squares. But if I try and include this one, so I draw the line more like this, then I'm going to include some squares. So I can't get a perfect classifier. In other words, the boundary, the decision boundary, is not linear. If I use a line, I can't get a perfect classifier. I can't get 100%. So that's what we mean by nonlinear classification boundary. Okay, now let's go back to the slide. Okay, I'm sorry, one more thing. We say that there is a function that can classify perfectly, but it's just not linear. So maybe it's this function here. There are actually many functions that we could draw, many curves or curves that we could draw that would do it perfectly, but they're definitely not linear. Okay, so we're trying to model this kind of curve with our process, and our process only generates lines for decision boundaries. So in this case, we couldn't get a perfect, our classifier wouldn't result in perfect classification. Now, I don't know if you're familiar with logic, true-false tables and so on or not, but I'm assuming here that you are. So we can talk about the OR logical operator OR, which actually can be kind of thought of as a function. And if you know what I'm talking about, you know that you can have either true or false, something that's either true or false on the left side of the OR, and something that's true or false on the right side of the OR. Like you might say, today is Monday, or it is raining. So the left side could be true, like today is actually Monday, or it might be false, today is not Monday. And the right side could be true or false also. It might be raining, it might not be raining. Okay, so each side is true or false. So we'll say 0 stands for false and 1 stands for true. So the left side will be x1, which will be either true or false. So it'll be either 0 or 1. And the right side will be either true or false. So it will be either 0 or 1. Now they're not putting it on the left side. They're just putting them both here. That doesn't matter. This just means put x1 on the left side and x2 on the right side of the OR. So so you know that if both left and right side are false, then the statement is false. So whereas any other situation, the statement is true. So this circle means false and triangle means true. So if the two are false, then you get something false. But any other configuration, for example, this one is false, but this one is true, then the resulting statement, the whole OR statement, is true. So we have this kind of picture. Can we classify this using a linear classifier and get perfect classification? Yeah. If we draw the line here, it works. And then you can do this one, it's just a different, slightly, well, this is the AND operator, and this means the negation of x1. So you can figure this out if you know what we're talking about. So you can do all of these with a linear classifier. You can separate them perfectly, triangles on one side and circles on the other. But there's some other very simple, these are very simple, or and so on are very simple, much more complicated, much simpler than that previous example we were talking about, the web pages and the Chinese. And but even something simple like the exclusive OR, that's what this means. I'm not sure what this means, but anyway, these, can you put a line between these that will classify it perfectly? No, it won't work. I guess what he's saying here is that I don't know actually, but anyway, no, you can't separate this one. So it can't solve into non-linearly separable problems. Okay? He says unless the input is transformed into a better representation, which I guess is what he's doing here.